We're asked to determine the cross slope of the roadway at station 53. We're given a set of design plans. We need to zoom in a little bit to see this in more detail. So here's looking at the portion of the roadway and the design plans that's associated with our station of interest. We have our PC at station 53 plus 48.44, so we know we're going to be slightly before that. And we are given here on the design plans, there's a 1%, for a 1% change in cross slope that's going to occur over a distance of 20.84 feet. So that's what we're going to use for these design plans. And if we look at this little tick mark here, this is where we're going to have our station 53. So that's our point of interest there. So we can get some information just from looking at this. We're going to need to do the calculations to find the precise value. But from what we can see on the design plans, our inside edge of pavement, our inside lane, is going to be at 2% because it's past this point here. So we know it's going to be at 2% there. And we're going to expect our outside lane to be somewhere between 0 and 1% cross slope. So we'll see if that plays out in the end, but we should start with thinking about what is a reasonable value we should expect from these design plans looking at station 53. So here's our typical equation looking for our tangent runout. Tangent runout L sub t equals to the super elevation runoff L sub r multiplied by normal crown over the design super elevation. I'm going to rearrange this a little bit. I want to solve actually for the runoff because we have enough information to find the runout. We also are given the design super elevation in our design plans. That's 4%, and we're going to use a normal crown of 2%. So that super elevation runoff, and we'll see where this comes to play on the next slide, is equal to the runout, which is where it occurs over 2%. So we need to multiply 2 times that 1% change distance, which was 20.84 feet, multiplied by our design super elevation of 4%, divided by our normal crown. That gives us a super elevation runoff of 83.36 feet. This is our classic diagram looking at how our cross slope changes, how it's related to our points on our horizontal curve. We're given our PC, station 53 plus 48.44. We were told our design super elevation from our design plans. We can calculate 2/3 of the runoff. We just calculated on the previous slide the full runoff, which was 83.36 feet. We're going to multiply by 2/3 to get that 2/3 of the runoff to get the adverse crown removed. That's labeled as point B here in this diagram. So we want to figure out what's the location, what's the station of this point. It's 55.57 feet before the PC. So we can do that math there. We're going to subtract that off from the PC station. So we're going to get a station of adverse crown removed, which occurs at point B, of 52 plus 92.87. So we know our station 53, our point of interest, is just past that. So again, we saw it on our plan view, our design plans, that we're going to expect the inside lane to be at 2% cross slope, and our outside lane is going to be slightly above 0. And we can see this happening in this perspective as well, looking at the cross slope and how all things are related. There are multiple ways to solve this, so you didn't necessarily have to go through these steps in this process, but I think this is a good way to visualize what's going on. But of course, there are more efficient ways to solve this. I'm trying to show the full explanation of how it looks from the plan view and then also from this cross section, or from this cross section, what's happening with the cross section and the profile of the project as well. So our station 53 is 7.13 feet from adverse crown removed. That's that point B, which had a station of 52 plus 92.87. We know that inside lane is at 2%, and that outside lane is slightly above 0, which I already said. And specifically, we just have to divide our 7.13 feet, the distance from point B, by how much it takes to change 1% in cross slope, 20.84, and that's going to give us a cross slope of 0.34%. So the answer to this, what's the cross slope at station 53? The inside lane is at 2%, the outside lane is at positive 0.34%.